In this video, we're going to discuss about stoichiometry and the Moore concept. Now, stoichiometry and the Moore concept is one of the fundamental or basic topics we need to know before we start basic chemistry topics. So this is one of the most important topics. It's an introductory topic to most of the topics we find in chemistry. So we need to be familiar with it. It deals with calculations relating to the Moore, so that's why we call it the Moore concept. Now, the first thing we need to know about stoichiometry and the Moore concept is the relative atomic mass. So what is the relative atomic mass? Or we can define the relative atomic mass as the number of times an atom is heavier than 1/12 of the mass of the carbon-12 atom. So what that means is each and every atom is just compared to the mass of a carbon atom. So how much is it heavier compared to the mass of the carbon-12 atom? So the relative atomic mass can be calculated by summing up the isotopes that make up an atom. So for example, let us look at chlorine. So we need to be familiar first with the formula on how we can calculate the relative atomic mass. And the formula is the relative abundance of the first isotope plus the relative abundance of the second isotope. It doesn't matter the number of isotopes, we just determine the relative atomic mass. So if there are 10, you add all the relative abundances. So for example, let us look at chlorine. Chlorine 35 and chlorine 37 in percentage compositions of 75% and 25% respectively. Then calculate the relative atomic mass of chlorine. So how do we solve this one? Given the formula, relative atomic mass is equal to the relative abundance of the first isotope. So an isotopes are atoms of the same element having the same number of protons but different number of neutrons. So that's why we see that we have chlorine 35 and chlorine 37. So the number of protons is the same, but the number of neutrons is different. So those are what we call the isotopes. So the relative atomic mass of chlorine, given chlorine 35 and chlorine 37 with percentages 75% and 25% respectively. So here is how we calculate this one. The relative atomic mass or the relative abundance is given by 35%. We are going to give the 35 of the chlorine 35 times the percentage 75% of the composition. Its composition is 75%. Then we are going to add 37 times 25%. Now we are going to let us first simplify the percentages. We know that 75% is the same as 75 divided by 100. So if we divide by 100, we can just divide everything, even the 35 by 100. So the percentage has gone. Then we add plus 37, we do the same times 25. So a percent, we're going to say divided by 100. So we say divided by 100. So if we are adding this and the denominators are the same, so we can say 100% is out of 100. So we're going to say 35 times 75. Then we add plus 37 times 25. So then we just perform the calculations. So that is 35 times 75 plus 37 times 25. Then we divide the answer by 100. So this gives me a 35.5. Here is another question. So it reads, the atomic mass of copper is 63.55. There are only two isotopes of copper, copper 63 with a mass of 62.93 atomic mass unit, and copper 65 with a mass of 64.93 atomic mass unit. What is the percentage of each isotope? Now you can pause the video and try it yourself before we start, okay? Alright, so here is how we go about this one. So we're given that the atomic mass unit of copper 63 is 62.93. So copper 63, its atomic mass unit is 62.93, and that of copper 65 is 64.93 atomic mass unit. Now the question is, what is the percentage of each isotope? Now how do we calculate this one? We know that a percentage is out of 100, so this means that when we add copper 63 and copper 65, they must give us 100%, and we only have the two of them. So we can say, we can let one of them to be an unknown number or an unknown letter. Let's say copper 63 is X. Let's say copper 63 is X. Now, if it's out of 100, it means we are saying we add copper 63 and copper 65 should give us 100%. So to get 100%, if copper 63 is X, we need to say 100 minus X. So that gives us copper 65, the percentage of copper 65. So we can just say, I'll just use a 1, and at the end I'm going to multiply by 100 because it's a percentage. So you can say 1 minus X. So this is copper 65. Now from our previous example, we know our formula the way it is. So we know that the relative abundance of the first isotope plus that of the second isotope gives us the relative atomic mass. So the relative atomic mass of copper is 63.55. So we just go direct. This is equal to the relative abundance of the first isotope. So the first isotope we're going to say is copper 62. Copper 63. So copper 63, we have the atomic mass of 62.93. 62.93, this is the atomic mass. Then we're going to multiply it with its percentage. So the percentage is X. We don't know the percentage, so we say it's X times X. So this is going to give us an X. Then we're going to say plus. So we have this part for copper 63. Then we come to copper 65. For copper 65, we have the atomic mass of 64.93. So we're saying 64.93. This we are multiplying with its percentage, which is 1 minus X. So this is giving, we're going to say 63.55 is equal to 62.93X. This is plus 64.93 times 1, so it gives 64.93. Then we multiply it by X, that's negative X, so 64.93X. Now we're going to take the 64.93 on the left side, so it's going to be 63.55 minus 64.93. This is equal to 62.93X minus 64.93x. So on the left hand side, we're going to say 63.55 minus 64.93. This gives a negative 1.38 on the right. So this is 62.93x minus 64.93x. This gives a negative 2. So we're having a negative 2x. And if we multiply both sides by negative 2, so we're going to cancel out this one. So x is equal to, we divide both sides by negative 2. So x is equal to 0.69. Now, the question is, what is the percentage of each isotope? So remember what we did. We said it is 1 minus x. So this is supposed to be 100. So even the x, we're going to multiply it by 100. And we said that it is, for copper 63, it is x. So for copper 63, we can say it is x, which is equal to 0.69. Now, for copper 65, we said it's x minus, it is 1 minus x. So this is 1 minus x, which is 0.69. So this gives us 0.31, and these are percentages, so we're going to multiply everything by 100. So 0.69 times 100. So we're going to get, for copper 63, it gives a 69%, and for copper 65, it's a 31%. So this is how we solve this one. Now I want to look at the formula ones. So in chemistry, we combine different elements to form a formula, to come up with a formula. So we can say it is a compound. For example, we can come up with carbon dioxide and say, to come up with carbon dioxide, it means we've combined carbon and oxygen. So that is carbon dioxide. It's a formula for carbon dioxide, which we can say it is CO2. So we want to look at the formulas of the masses of such compounds or formulas. So let us look at carbon dioxide, the first one. So we're going to say carbon dioxide is CO2. So now, the first thing we need to understand when we want to find the formula mass of a certain compound, we need to know its relative atomic mass, the relative atomic mass of each element. So that's the first thing we need to know. Then secondly, we need to take into consideration the number of each element present. So in this example, we have 1 carbon atom and 2 oxygen atoms. Then the third thing is, after we've calculated, we just add. So here's what we're talking about. Let us start with this one, carbon dioxide. So we know that the relative atomic mass of carbon is approximately 12. So we say 12. We multiply it. How many carbon atoms do we have there? We only have 1. So we say 12 times 1. Then we say plus. How many oxygen atoms do we have? We have 2. And what is the relative atomic mass of oxygen? So it's 16. So it's 16 times 2. So this is how we calculate. Then we just get the calculator. So we say 16 times 12 times 2 rather, that is 32 plus 12, that is 44. So the relative atomic mass or the formula mass of carbon dioxide is 44. You can say 44 grams per mole. So this is how we go about it. Another example can be ammonia. Ammonia, we know it's NH3. This is its formula. This is the compound ammonia. So for nitrogen, we know that the relative atomic mass of nitrogen is 14. So this is 14 times, how many nitrogen atoms do we have? We have 1. So it's 14 times 1 plus the relative atomic mass of hydrogen, I'll say it's approximately 1. So let's just use 1. So this is 1 times. Then we have 3 hydrogen atoms. So when we multiply 14 times 1, that is 14. Then 14 plus 3. So this is because 1 times 3 is 3. So we are going to get 17 grams per mole. Let us look at glucose. Glucose is C6H12O6. So we do the same. So we say 6. So we know that the relative atomic mass of carbon is 12. So it's 12 times 6 because we have 6 atoms of carbon. So we say plus the relative atomic mass of hydrogen is approximately 1. So that is 1 times 12. Then we say plus for oxygen is 16, approximately 16. So 16 times 6, the number of oxygen atoms rather we have. So 12 times 6, that is 72, plus 12 plus 6 times 16 is 96. So when we add 72 plus 12 plus 96, this is 180.